meaning of the data mining, the objective is the data mining. So the meaning of data mining is it's a computational process, means it's done by computers of discovering the patterns. So the idea of data mining is to understand the patterns in large data set with an objective. So there are large data sets. So there are like maybe thousands of rows of data or millions of rows of data, and with an objective. So you have an objective in your mind. So data mining does not happen if you do not have an objective. You cannot just go and do a data mining, right? When you are going for fishing, you need to have an objective, right? That you want to catch maybe 10 fishes, or you want to catch a fish. You are not just saying, okay, I go to the river and maybe if there are fish, I will catch them. Not like this, right? So you are trying to do data mining with an objective in your mind. So you want to understand the patterns, and data mining helps only with the patterns. So you have an objective in your mind that you want to understand some patterns. And then you are doing some computational process, means via computer. That is called the data mining. So it's to extract the data from a data set and transform it into understandable structure. And then, aside from the raw analysis, it also involves database management aspects. It also involves data pre-processing. We will learn that a bit in a bit of more details. Model and inference consideration, intersection metrics. These are all technical details. Include the visualization and the online updating into your dashboards and everything. So that is all a part of data mining. So that is the data mining at the intersection of many disciplines. So data mining involves a lot of things. So it includes mathematical modeling, it includes statistics, regression analysis, permutation combinations, and time series analysis. It involves pattern recognition, it involves machine learning, it involves knowledge of database, it involves management science and information system, and it involves artificial intelligence. So that is the all when all these are intersected, that's the data mining. So this is looks something like a Venn diagram, right? So if you see the data mining in terms of how where it does sit in our organizations. So the basic model is your data source, where it's papers, files, information provider, database system, or your transaction processing system, your ERP and your other things, right? So that normally is managed by the database administrators. Above that, you see data warehouse and data marts. So there are OLAP, analytical procedures, and the management of database. So that these two jobs are done by database administration. But here you don't have all the decisions. You cannot make decisions, right? Because this is just a data. You have no idea, you have no understanding of it. But then we do the data exploration, which is called the statistical analysis, querying and reporting the data, and then we do the data mining to find the information from this particular data. So that is the job of the data analyst. So these two are the job of data analyst. And then this data is given to the business analyst, who is going to present the data and use the visualization techniques, maybe by charts, by pie charts, or by the diagrams that we saw last week. And then it will submit to the end user. Who is the end user? The management. And those are going to make the decisions. So the higher information is available, they have a potential to support the business decision. So business decisions cannot be made on the data source itself, right? Because there is no analyticals, there's no analytics happening there. When it's go to the data mart, also is not helpful because there is no analysis yet of the data. After this, the data exploration and data mining helps. So there you have much more potential to support the business decisions, and the highest potential is in the data presentation. So when you are able to present the data into a simple format, or into a summary or a synthesized way, then you are able to make the decisions. So that's the highest potential. So this is the structure of the data mining in between the business, from the data warehouse that we have learned, and the business decisions. So we have actually learned the data visualization and presentation and make how we make decisions. We learned yesterday about the data warehouse and data sources. Now we are looking at the information discovery part. Clear, right? Hello? Yeah. Okay. My voice is still breaking. So did we have looked at the data taxonomy already, right? We understood there are structured data and there are unstructured data. So what was the structured data? Can anybody tell me? The structure.
The structured data is basically like you have been organized with all the subcodes, codes, and everything.
So basically is the numbers which can be organized into a table or can be organized into a text, correct? And unstructured data is more on the which is not numerical, which is not numbered, which is not which you cannot organize into tables, right? So that is the text, audio, video, visuals. So those are not a structured data, right? They are unstructured data, correct? Or semi-structured. So the structured data also again is categorized into two, which is one is categorical and one is numerical. So categorical means which is like a range, a color, red, blue, green. So these are the categories, right? The colors and the numbers 1, 2, 3, 4, 5, 6. They are called numericals, right? Numericals can also further be divided into intervals or ratio. So ratio is the percentage, interval are the time series, and then you have nominal or ordinal. So these are basically the data taxonomy, how we describe the data. So ordinal means which you can order from 0 to 1. So for example, January, February, March, April, May, June, July will be ordinal because you can put them in a order, ascending order or descending order. Nominal means you cannot order them, right? So these are like colors. Can you order the colors into which color should come first? No, right? The colors is color. And then the table. So these are the ordinal nominal data. Ordinal data which you can ascend, descend, put it and then sort them into descending order or ascending order. So this is the data taxonomy. It's not that really key. The process of the data mining is the cleaning of the data. So whenever there is a data, the data mining, the first process in data mining is to clean it up to and sort the data, identify the outliers that we will look into the future slides, and then put into the data warehouse, and then do the data mining. So the process not only starts with the algorithms, it starts with the pre-processing. So that is the cleaning and integration of data, which we saw in our data warehouse as well. Okay, the similar process. So there are four stages. One is pre-processing, which means we assemble the data, we clean the data. The cleaning the data means there are noise. So what is a noise? Does anybody know what is a noise? Have you seen the wavelength, like the if you have seen your own recording, right? And the if you see your waves, correct? The sound waves, and in the middle, if you tap something, yeah, so these are waves. So the noise means which is not a normal voice, means it's not a normal sound. Noise means the sudden spikes in the wavelength. So for example, when I'm talking to you now and I say, okay, uh, so this is called a noise, means when you put into a wavelength, it will go up, it will shoot up very quickly because there is a sudden noise, right? So these are called noise, which you cannot hear anymore. or which will make you not able to understand the data. So noise means, so for example, if let's say everybody of you has a average salary of $2,000, somebody will have, let's say, $1,000 per month, somebody will have 1,200, somebody will have 1,300, somebody will have up to 2,000. What if any one of you has $100,000 a month? So what do you think, what will happen to the average? If there are, let's say, 10 people, 10 people have average salary between 1,000 to 2,000, so the average will be where? Somewhere between 1,000, right? But if one of you has a salary of $100,000, so what will be the average becomes? Average will be more than 10,000, right? But that's not the reality, correct? The reality is majority of you are between 1,000 to 2,000. But if you combine all together, the average will become 10,000. So that is called a noise, which is going to destroy the average of all the things. So the how you identify the noise, you just see the wavelengths and say, oh, this is too high or this is too low. So those are called noise. So you have to remove the noise when you are cleaning the data. You have to remove the missing data. You have to fill up the missing data. So if let's say there is some fields are missing, when you are extracting the information from the system, certain variables are missing. So either you have two ways, either you assume something and put it there, or you ignore that row. But if there are too many rows which are missing, the data may not be useful anyway. So you have to fill up that data. The second process is the mining. The mining has many processes, which is called the anomaly detection, means the data is not normal. Then you have the dependency modeling. What are the predictions? So identify the patterns. The clustering, is there any specific clusters of patterns? The classification, we will learn these terms a bit in a bit detail later on. Regression analysis, and the summarization. So these are the process in mining process. These are the mining process. And then finally you do the result validation. So in data mining, normally we divide the data into three parts. One is where you are going to create the models, understanding those models. Then there is a test data. The test data will help you to understand and validate your with your models. And then there will be actual data which on which you will be using the data mining these algorithms to understand if the result is clear or not. So that is the different stages. So you have a result validation. These are three stage in data mining. First stage is pre-processing. Second stage is the mining. Third stage is the result validation. So we are going to look at each of them one by one. So the steps in data mining, the first step is the steps before we go into the stages, the steps in data mining is the purpose. So you have a one-time answer to some questions, and then you may have a one-time question to answer, means you just want to know now only, but you will not be able to use in the future. And you sometimes have to understand the continuously, you may want to ask the same question again and again, but there has to be a purpose. You have to understand what is my purpose to identify the data. For example, when Google is doing the data mining of your search results, they have an objective. They want to understand and clusterize you into and understand the patterns. What do you like, right? What is your profile? What kind of ads they want to show you? So they have a purpose. So when you are doing a data mining, you have to have a purpose in your mind, clear purpose in your mind. And then the second step is capture these sample data sets. So they are random sampling. Data can come from the different database. It can be internal or external. Usually the data mining happens only with about 10,000 rows of data. If you put in Excel, then about 10,000 rows are just about sufficient for doing the data mining. Not, you don't need more than that. Then you do the exploring and cleaning of the data, means identify the noise, as I explained earlier. Then you remove the missing data or fill up the missing data. Then you will reduce the data set into three: training, validation, and testing. So training means Basically it's like you are training your mind with the examples, right? With the which we saw in the previous example when we were selecting the eye testing, whether you get whether you get the classes or not. So there has to be a training data, which means you are going to understand whether there is a what is the result, what has been the variables and what has been the result, so that you can draw the algorithms based on that. And then some data set will be there to validate the algorithm whether they are correct or not. And then finally you will test, and then you will determine the task techniques to be used, and then you will use the algorithm to interpret the results. So that's that means the deployment of model. So we will not go into details of every single step, but we will look at some of the stages in more details. So we will look at the prelim steps before lunch break, so that you have so your minds get cooled down with so much technical details, right? So the prelim steps was organization. Organization is means that the data so you are basically collecting the data and constructing them into variables in columns and records in rows. So that's the basic structure. So all the variables you put into columns, and then there will be a final column for the result, which we saw an example in the previous slide of our recommendation of classes. And the rows are the actual data. Then you select a sample. Sample is choose one sample to build the analysis algorithm. The shorter the data is better, right? Because you don't want to have a huge data for just for the driving the algorithm, because then it's more confusing. And then you will do the pre-processing. So you will choose the variables. Now variables should be numeric. You don't want to create variables which are non-numeric, because or text like yes no, like logical text. Otherwise it will be very difficult to draw them or make them alignment into the results. Or it can be continuous, assume any value or integer. And then you finally do the selection, need to be based on the objectives, and it should be clear. You don't want all the variables which are you need to choose which variables are going to affect a decision, right? For example, if even in the first example that we gave in the cow culling or in the in vitro, not all 700 features are relevant, not all 60 features may be relevant. So you may need to choose the variables which are actually relevant and make any decision, make any impact on the decision that we are taking. So there may be few variables which we are actually looking at, right? So those are the only variables which we will be choosing, focusing on. The rest we will ignore. Then when you are doing the cleaning of the data, there are usually outliers, i.e. the noise makers. So these data errors which will be impacting the analysis. So you have to remove the outliers. So normally to remove the outliers, you use the standard deviation. Everybody knows standard deviation, right? What is the standard deviation? Hello?
Plus minus some variation.
No, but what is the standard deviation? How you calculate the standard deviation? What is the meaning of standard deviation? Does anybody has any idea?
Long time ago.
Yeah, you might have read it like maybe in your 10th standard.
Time ago,
Yeah.
and it's all about stats.
Yeah, it's a statistical thing. It's a statistical term. So the standard deviation, but everybody know average, right? Everybody know mean, right? So if you have 10 data points, if I ask you to calculate the average, you will be able to calculate that, correct? So basically, the standard deviation is a measurement of how far your data is from that particular average, right? So the way to calculate this is basically, um, you are calculating the average first, and then you will calculate the difference between the average and each data point separately, and then you will square that distance and divide by the number of items, and then calculate the square root. So that will give you the standard deviation. So normally a standard deviation is, it becomes like a chart bell curve. So up to 3 plus minus 3 will contain 95% of all the data. There will be some data points which are more than 3 points away from the standard deviation, but those should be ignored because they are considered as outliers. So it means that the difference between the average and the data point is too high. So that's why we, in the statistical term, we calculate standard deviation. So the data distance points, if it's more than plus minus 3 standard deviations, it will be ignored. So they will remove that data from our analysis, because that will be considered as outlier. So I would suggest you go to the Google and search what is plus minus 3 standard deviation. That's very simple, not very difficult. So the objective is to either identify the outliers and understand the explanation. So we just not review it. Maybe it need to be reviewed by a domain expert, maybe somebody who need to explain why there is a difference. Maybe there is a reason for that, right? So you may not just ignore it, but you want to understand it by a domain expert. So there are some simple ways. One simple way is sort by large item and small item. So sort by ascending, so you will get the largest. Sort by descending, you get the largest amount. Sort by ascending, you get the smallest amount, and then you will know what are the distant points, right? So that's easy way. Or use minimum maximum function in available in the Excel. So that is, you can do and try to identify the outliers. So that if there is no outlier, then is okay. If there are outliers, you may want to get an explanation and how many of them are there. Then the missing records also need to be taken care of. The missing records means that the some data is either so it is missing. So there are few choices. Either you omit the record, means you remove the record from the sample. But if there are too many and you remove it, then you will not have enough information left. So it means you may have to recollect the data. So if, or the other choice is to replace the missing value with the mean average, not the outlier, na, with the average. So that again, if it's too many, then also is not going to be good, because that would affect the average. So if it's a large number of records which has a missing value, you should do either use the other variable or find another data set. That's the only time. Pre-normalization, I will not go into details, because that's a bit of more, again, statistical explanation. But normalization basically means sometimes you have different ways of variables. So let's say in some variables are in kilogram, right? Maybe in the kilo. Some variables are in grams. So in 1 kilo there are 1000 grams. So if when you are using the data techniques, if you leave them as their original units, it will affect the algorithm, it will affect the clustering, it will affect the distance from the mean, and then it will be very difficult to get a proper analysis. So there is a system called normalization, which calculates the distance from the mean by standard deviation to normalize the data. But that's a bit technical term. You don't have to worry about this. The systems are already nowadays doing it automatically. When they store the data, they normalize the by themselves immediately.